Hello students, welcome to Akash Live. I'm your mathematics faculty and today we're going to discuss the quick solutions of AIATS for JEE Advanced 2019, test number 3A paper 2. The syllabus for this particular test is the complete syllabus of class 12th. Okay, so this test was held on 27th of January 2019 and let us begin the solution discussion with question number 41. The value of limit x tends to 0, e raised to power sin x minus cos of sin x whole divided by root of 1 minus cos x is. Students, as we can see that there is under root in the denominator, so let us consider LHL and RHL separately. Okay, so for LHL I'll have f of a minus h, that is 0 minus h. Okay, so limit h tends to 0, e raised to power sine of 0 minus h, that is minus sin h, minus cos of sine of 0 minus h. Sine of 0 minus h will be minus sin h, and cos of minus theta is simply cos theta. So cos of sin h whole divided by 1 minus cos of 0 minus h. So cos of minus theta is cos theta. So under root of 1 minus cos h. So that can be written as 2 sin square h by 2. H by 2. So students, remember that h is always a positive quantity. So we have limit h tends to 0, e raised to the power minus sin h minus cos of sin h whole divided by root 2 mod of sin h by 2, and that will be simply sin h by 2. So sin of h by 2. So students, as we have 0 by 0 form, so let us apply L'Hospital rule. So differentiating numerator and denominator separately, will get limit h tends to 0. E raised to power minus x, the differentiation is e raised to power minus x, that is same, minus sin h into minus of cos h. That is the differentiation of minus sin h. Minus differentiation of cos of sin h is minus sin of sin h. So plus sin of sin h multiplied by differentiation of sin h is cos h whole divided by root 2 cos h by 2 into 1 by 2. So students, as we put h tends to 0, we have e raised to power minus 0, that is 1 into minus 1 plus 0. So minus 1 plus 0 upon 1 by root 2. So we have minus root 2 as the answer for the LHL of this particular limit. Now let us consider the RHL. Again, limit h tends to 0. In this we will be very smooth. E raised to power sin h will be there, minus cos of sin h will be there, whole divided by, again, under root of 1 minus cos h, so that can be written as 2 sin square h by 2. Further, we will have limit h tends to 0, e raised to the power sin h minus cos of sin h whole divided by root 2 into mod sin h by 2, h is positive, so root 2 into sin h by 2 simply. So we will solve it by L'Hospital rule again. Limit h tends to 0, e raised to power sin h, the differentiation is e raised to power sin h into cos h, minus cos of sin h will be plus sin of sin h into cos h whole divided by root 2 into cos h by 2 into 1 by 2. So we have the answer as 1 plus 0 by 1 by root 2. So that is root 2. Clearly, LHL is not equal to RHL. Therefore, the limit will not exist. Option number D will be the correct choice. Okay. Let us move on to question number 42. Talking about question number 42, which is based on continuity, it says that the number of points lying in the interval open 0 to 2 pi at which the function fx given as greatest integer of sine square x is discontinuous, where this square bracket obviously represents the greatest integer function over there. Okay, so let us draw the graphs. It is a very simple question. You just have to draw the graph of greatest integer of sine square x and then you are done with it. So over here, let us have the y-axis. This is the x-axis. Again x-axis. So y equal to sine x, something like this. Okay, this is obviously 0, pi, 2 pi. This is y equals sine x. When we draw the graph of y equal to sine square x, we know that in the first quadrant as well as in the second quadrant sin x is positive, lying between 0 to 1. Sin square x again lies between 0 to 1. The nature of the graph changes something like this. Further, in the third and the fourth quadrant, no doubt sin x is negative, but sin square x will be a positive quantity. Again, something like this. Fine. So very symmetrical graph, maximum value 1, minimum value 0. This is the graph of y equal to sin square x. This value is pi by 2 obviously. This value is 3 pi by 2. Now students, when we draw the graph of greatest integer of sin square x. So sin square x is a quantity lying between 0 to 1, both intervals closed. So either the greatest integer of sin square x will be 0 or it will be 1. So sin square x is 1 at two particular points, 1 and pi by 2 and 3 pi by 2. So when we draw greatest integer of sin square x, we can see that from 0 to pi by 2, it is 0. At pi by 2, we will be having an open interval because the value is 1. Then again from pi by 2 to pi, 0. At pi again 0, closed interval. Then from pi by 2 to 3 pi by 2, at 3 pi by 2 will be a hollow circle. And over here again a closed circle. And then again till 2 pi, we have the values lying between 0 to 1. So wherever the value is lying between closed interval 0 to open interval 1, the answer is 0. Otherwise it is 1 when sin square x equals 1. Now students, I need to answer the number of points of discontinuity of this red graph, that is clearly pi by 2 and 3 pi by 2. Only 2 points of discontinuity. Okay. So option number B is correct. Let us move further to question number 43. Okay. So question number 43 says that if fx equal to 0 is a cubic polynomial equation with 3 positive and distinct roots, x1, x2 and x3, such that x2 is the harmonic mean of the roots of f dash x equals 0, then x1, x2, x3 are in which particular progression? AP, GP, HP and AGP with non-zero common difference. Okay. So let us have the question. So let us start the question with assuming a cubic polynomial fx equals 0 with 3 positive and distinct roots x1, x2, x3. So all of you know that fx can be easily taken as a times x minus x1 into x minus x2 into x minus x3. Okay students, so now let us write fx in the other form by opening up the brackets. X cube minus sigma xi, that is x1 plus x2 plus x3 times x square, plus sigma xi xj, that means x1 x2 plus x2 x3 plus x1 x3 into x, minus pi, that is the product for symbol, xi, that means x1 into x2 into x3. Okay, this is the expanded form by using theory of equations. All of you know this. Now students, it is given that x2 is the harmonic mean of the roots of f dash x equals 0. So let us differentiate it and apply the given condition. So f dash x will be a times 3x square minus 2 sigma xi times x plus sigma xi into xj. Okay. Now let us assume that the roots of this particular quadratic equation are alpha and beta. We know that 2 alpha beta upon alpha plus beta is given to be equal to x2. So 2 alpha beta upon alpha plus beta is given to be x2. What is 2 alpha beta? 2 times constant term divided by the leading coefficient. What is alpha plus beta? Minus times coefficient of x divided by coefficient of x square. So this will be 2 times c by minus b. So c is sigma xi xj, that is x1 x2 plus x2 x3 plus x1 x3, directly cancelling the leading coefficient as well as this a, that is a constant, whole divided by alpha plus beta, that means 2 times x1 plus x2 plus x3. This is equal to x2. So from here what we will get? 2 will be cancelled. x1 x2 plus x2 x3 plus x1 x3 will be equal to x1 x2 plus x2 square plus x2 x3. Students, we can see that 2 terms are cancelled. This is cancelled and this is cancelled. The final result that I'll get is x1 x3 is equal to x2 square. Obviously, it is a result of a geometric progression. Okay, first term into third term is equal to middle term square. Option number B goes correct. Fine. So it is a very conceptual problem mixing two particular concepts, that is theory of equations as well as sequence and series. Let us move on to question number 44. So question number 44 says that let a polynomial function fx be given as ax cube plus bx square plus cx plus d, where a is non-zero. So that is a standard cubic polynomial function, has x equals plus minus 1 as its points of local extremum. Then we know that at points of local extremum f dash x will be equal to 0. So that means f dash x can be straight away assumed as lambda times x square minus 1. Because x square minus 1 equals 0 has the roots x equals plus minus 1. So this is lambda x square minus lambda. That is f dash x. So what is fx? By integrating this particular thing, we have lambda by 3x cube minus lambda x plus constant of integration, let us say k, because c is already there. Fx is ax cube plus bx square plus cx plus d. So from here I can say that a is equal to lambda by 3, b is equals to 0, c is equals to minus lambda, and d is equal to the constant of integration. Now students, we can see that c is equal to minus 3a. Yes. And b equal to 0, d equal to k. So c equal to minus 3, that means c by a equals minus 3. C is the correct answer. Okay. So obviously we can see that b is equal to 1 is the wrong option. A plus c equals 0. A is non-zero, c is non-zero because c is minus 3a. So a plus c can never be equal to 0. D equal to 0 is one of the possibility, but it does not satisfy the condition given in the question. That means this option is also wrong. Let us move on to question number 45. Question number 45 says that let fx equals sin x into e raised to the power cos x minus cos x into e raised to the power sin x, where x belongs to the open interval 0 to 2 pi. The sum of lengths of the intervals of x for which fx is taking negative values, that means fx is less than 0, is equal to what? So we have to figure out the intervals over where fx is negative, and we have to find the sum of lengths of those particular intervals. Okay, so let us start it. Fx is sin x into e raised to the power cos x minus cos x into e raised to the power sin x. Let us take sin x cos x common. Multiplied by e raised to the power cos x upon cos x minus e raised to the power sin x upon sin x. Now students, in 0 to 2 pi, we know what is the behavior of sine and cos. We can decide their positive and negative values. For this particular bracket, I will have to assume another function g of t as e raised to power t upon t in order to analyze this particular bracket. So let us analyze this function gt. It is e raised to power t upon t. G dash t will be, applying the quotient rule, t square t into differentiation of numerator, so e power t, minus e power t into differentiation of denominator, that is 1. So e power t into t minus 1 upon t square. As far as my bracket is concerned, I have to put t either as cos x or as sin x. So we can see that gt is a decreasing function. How decreasing function? Because for t less than 1, g dash t is going to be negative. E raised to power t is always positive, t square is always positive. So for t less than 1, it is going to be a negative quantity, g dash t. Therefore, gt will be a decreasing function. That means we have got that this particular bracket is decreasing for all values of cos x and sin x lying in the interval minus 1 to 1. Okay. So let us analyze the sign of fx now. Fx is sin x into cos x into e raised to the power cos x by cos x minus e raised to the power sin x by sin x. Let us mark some particular intervals along with the graphs of sin x and cos x. This is sin x graph. This is the graph of cos x. So let us mark certain points: pi by 4, pi by 2, pi, pi plus pi by 4, 3 pi by 2 and 2 pi. Okay. So this is pi by 4, pi by 2, pi, 5 pi by 4, 3 pi by 2 and 2 pi. Students, from 0 to pi by 4, sin x cos x both positive, so outer term positive. Cos x is greater than sin x. So if cos x is greater than sin x, this particular quantity inside the bracket is going to be negative because it is a decreasing function. So it is negative from 0 to pi by 4. Obviously, from pi by 4 to pi by 2, when I shift this interval, now sin x is greater but both are positive. So the whole value is positive. Okay. Next, from pi by 2 to pi, now sin x is greater, so this bracket is positive. Sin x is positive but cos x is negative, so that means we have negative value. Again, in the next bracket, what will happen? Both will become negative, still sin x is greater than cos x, so this is positive. Then again in the next bracket, what happens? Cos x crosses sin x. So if cos x crosses sin x, there is one change, both are negative, so the sign changes. In the last interval, what happens? Cos x becomes positive, so it is positive. Okay, so we have 3 intervals. That means the intervals under consideration are: for fx negative, x belongs to 0 to pi by 4, union, pi by 2 to pi, union, 5 pi by 4 to 3 pi by 2. So what is the total length of interval? Length of the interval it is pi by 4 plus pi by 2 plus again pi by 4. So that means it is equal to pi, which means that option number C is the correct choice. Okay, let us move on to 46. Question number 46, based on probability, it says that for a biased die, the probabilities for different faces to turn up are given below. Face 1, 2, 3, 4, 5, 6 and the corresponding probabilities are given: 0.2, 0.05, 0.15, 0.3, 0.2, 0.1. The die is tossed and it is found that either phase 2 or 3 has turned up, so it is conditional probability. Then the probability that it is phase 3 is. Okay, so we have to find out probability that phase 3 came up given 2 or 3 came up. So probability of A given B is probability of A intersection B, 3 intersection 2 union 3 upon probability of 2 union 3. So simply we can see that numerator will be probability of 3 simply divided by probability of 2 plus probability of 3, since they are mutually exclusive events. Okay, probability of 3 0.15, probability of 2 0.05 plus 0.15, probability of 3. Straight away 15 by 20 or 3 by 4. We have option number D as the right choice. Okay, simple one. Let us move on to 47. Question number 47, based on applications of integrals, says that the area bounded by the curves x square plus y square minus 2x equals 0 and y power 4 minus 2y square minus x square plus 2x equals 0 is. So students, the first curve is a circle, x square plus y square minus 2x equals 0. That is x minus 1 whole square plus y square equals 1. Circle with center 1, 0, radius equal to 1 units. Now, let us analyze the second curve. Y power 4 minus 2y square. Let us add 1 equals x square minus 2x. Let us add 1. So y square minus 1 whole square equals x minus 1 whole square. So y square minus 1 equals plus minus x minus 1. So y square equals x and y square equals 2 minus x. Two different parabolas having axis along x-axis. So let us draw the diagram for this particular problem. So y square equals to x is a rightward opening parabola, something like this. Y square equals 2 minus x is a leftward opening parabola, something like this. And this circle is passing through 0, 0, that is the vertex of first parabola, 2, 0, the vertex of the second parabola, both the points of intersection 1, 1 and 1, minus 1. So this is the circle. Okay. So we need the area bounded by these curves. The area will be the sum of these 4 small areas, 1, 2, 3 and 4. Obviously these 4 areas are symmetrical. So total area can be written as 4 times area of 1/4 of the circle. Let us say that is pi r square by 4 minus, if I count it here from 0 to 1, y square equals x. 0 to 1 root x dx. So this is 4 times pi by 4 minus 2 by 3. So that is pi minus 8 by 3 square units. Okay. Option number D goes correct. Fine. So very conceptual problem as far as the diagrams are concerned. You have to be very careful while calculating the area. Okay. Let us move on to 48. Question number 48 says that the centroid of the triangle ABC is G and the centroid of the triangle AGB is G1. If G divides G1C in the ratio 1 is to lambda, then what is the value of lambda? So students, let us have a simple diagram of triangle ABC. This point is the centroid G. We have to find out the centroid of triangle AGB. So let us join these points. And if the centroid of the triangle AGB is G1, I need the ratio in which G divides G1C. So let us say this is CG. And over here, when we'll produce it, we'll get a point G1 here. So we have to use one particular property. What is that property? The property is that the centroid divides the median in the ratio 2 is to 1. Okay. So GG1, let us say 2K. And G1F will be K. Okay. Similarly, CG will be 2 lambda. And GF will be lambda. So GF in terms of K is 3K. So 3K is equal to lambda. Now I need the ratio G divides G1C in the ratio 1 is to lambda. So G divides G1C in the ratio 2K is to. So this is the relation relating lambda and K. I have assumed two constants in this particular equation. Now I need the ratio in which G divides the join of G1C. So what is G1G? So what is G1G? G1G is 2K. Simple. Now, in terms of K, I need the value of GC. So, GC is 2 lambda or CG is 2 lambda, so which will be equal to ultimately 6K. The ratio is 1 upon lambda equals to GG1 upon GC, which is 2K upon 6K, and that is 1 by 3. So, lambda is simply equal to 3. Fine. Option number D goes correct. Let us move on to question number 49. So, question number 49 says that the value of the definite integral 0 to 1 3x minus 4x cube under root of 1 minus x squared dx is equal to what? This particular expression is straight away giving you the hint that you should put x equal to sine theta. So if x is equal to sine theta, we have dx is equal to cos theta d theta. Under root of 1 minus x squared will be cos theta. Limits will be from 0 to pi by 2. So it is 0 to pi by 2. 3 sine theta minus 4 sine cube theta. Multiplied by cos square theta d theta. That is from 0 to pi by 2. 3 cos square theta into sin theta d theta minus 4 cos square theta into sin square theta into sin theta d theta. That is ultimately sin cube theta. Okay, from 0 to pi by 2. In both the integrals, I'll put cos theta as t. So from 1 to 0, 3t square minus dt. And again, from 1 to 0, 4t square into 1 minus t square into minus dt. So minus will be adjusted in the limits. It will be t cube from 0 to 1 minus 4t cube by 3 minus 4t power 5 by 5 from 0 to 1. Answer will come out to be equal to 7 upon 50. Okay, option number C is correct. Fine. Let us move on to the next section, which contains multiple correct type questions. Okay.